Well, scientists argue that intelligent design doesn't represent any research program. If you believe in intelligent design, that doesn't represent any research program within the mainstream scientific community. And basically, it's still essentially creationism. In the United States, listen, church, creationists and proponents of evolution are engaged in a long-standing battle over the legal status of creation and evolution in the public school science classroom. August 1st, this was interesting, 2005, George W. Bush, President George W. Bush, he commented endorsing the teaching of intelligent design alongside evolution. And here's what he said: I felt like both sides should be properly taught, so people could understand what the debate was actually about. I think that's cool. So, here are questions I think that are very important for us to explore this morning. Are science and faith in a creator compatible? Are science, don't say yes, you don't know the answer yet until you will in about 45 minutes. Are science and faith in a creator compatible? Here's another question. More specifically, is every aspect of the theory of evolution incompatible with belief in intelligent design? Every part of the idea of evolution. In my judgment, God created the heavens and the earth. In my educated judgment, from what I've learned in my life here, I believe firmly that God created the heavens and the earth and all that inhabits it. And utilizing science to unveil his marvelous work. Would you agree? Look at your neighbor and just say, you are a marvelous work. Listen, I believe that utilizing science to unveil God's incredible design before us is an amazing gift. I do. As long as we don't eliminate him along the way, right? And to ignore, listen, church, to just ignore, just put a wall up to mainstream scientific movements in our own society without examining what they are and the impact they have on people's worldview is irresponsible. To bury our head in the sand as Christians and just to ignore what the major movements are scientifically around us is dumb. And here's why. Because how are we then properly going to evangelize about a creator with conviction? And if we're to turn people, are you with me? Do you want to see people turn their hearts towards Christ? He's still the hope of the world, especially in this current young generation. We've got to take to heart 1 Peter 3:15. Peter writes this, "But in your hearts honor Christ the Lord as holy, always being prepared to make a defense to anyone who asks you for a reason for the hope that's in you. And yet do it," this is important, "with gentleness and respect." Gentleness and respect. So my heart this morning as your pastor is that we would continually equip ourselves on this particular debate. And it just so happens that we literally have a scientific expert. I'm not kidding. Yeah, sure, clap, that's really good. On the subject, right here in our church body. Chuck and I love Chuck. We had dinner this week, and I came away thinking, I really like that guy, and he's a lot smarter than I am, and it ticked me off. But no, he's just an awesome guy. But listen, he has over 30 years of biotechnology industry experience, a broad scientific and operational understanding of recombinant protein, plasma protein, natural virus, and cell-based products. We talked about that. Fascinating. With leadership skills necessary to bring promising new products, some of these healing, life-changing products, through the development to the market. He has listen to this, He plays bass pretty well, but he's just not the sharpest knife in the drawer. Listen, he's got a double college major in biology and chemistry. I took chemistry in high school, by the way, just so you know. He has a master's degree in chemistry, and he has a doctoral degree in biochemistry. Yeah, super cool. And he plays a mean bass. He's awesome. Chuck is he's a drug developer with a unique, well, that sounds, yeah. So if you're looking for a dealer, that's your man. No, I'm kidding. No. He is a drug developer. Again, very, sometimes in medical field, life-changing things that can probably potentially save lives, with a unique scientific understanding, a broad operational experience for protein-based products. He's with a significant early portion of his career as a scientist at Genentech and a staff scientist at Bayer. Chuck subsequently held management positions with increasing levels at major drug companies. He's currently, this is recent, the CTO, Chief Technical Officer at Anthera Pharmaceuticals. So, with those questions in mind and whatever else you want to talk about, I want you to listen carefully. And the idea is that I just think it's paramount for us as Christians to talk and learn intelligently what science, what the movements are right now and how they affect our worldview and the worldview of those around us. All right, so let's welcome Chuck up.
All right, you know how like when you see those commercials and at the very end in small print, there's a bunch of disclaimers, so I'm going to put those up front. So, number one, things I say are my opinion. There's a lot of noise in this area. If you go on the internet, it's shocking. I mean, of course, the internet is shocking in and of itself, but shocking how much information there is, and you can draw a lot of information. And in general, when we talk, I'll talk to you, as a scientist. I am a biochemist. If you ask me things about biochemistry, about protein synthesis, about those kinds of things, I can give you a super clear answer. But we're not going to be talking about those things. So once again, these are my opinion of things as a scientist, but having reviewed a bunch of information. So in general, any given subject matter, a relatively small group of experts will generate a prevailing view. This goes in any area. It goes in theology, goes in biochemistry, talk about astrology, astronomy. Astrology probably different too. So in you'll have a few smart people, and I'm not saying these are dumb people. These will be super smart people, way smarter than me, and they'll come up with an idea that then gets disseminated in the community. And in general, because the rest of us don't have time or the energy to research those things, we'll accept that position, and that goes with what we're going to talk about today. As a scientist, I prefer hard data. So I prefer to be able to actually do an experiment, not that I do many experiments anymore, and then look at the data and go, oh, okay, come to a conclusion based on, a hypothesis, scientific method. But there's a lot of data here, most of which I have not personally seen. So once again, we're going to be gleaning stuff out of the literature. Science is based on theory, some things that can be tested, those are experiments, some things that you can observe, so there's some evidence out there, usually historical in nature, and other things you just kind of infer, and this is not just in science, but also in other areas. I mean, if you're a detective, you're out there looking around, looking for evidence. Oh, this color's not good. Sorry, I didn't really test this, so I'm going to step down here so I can read this. Some things we'll talk about are scientific, others are theological, philosophical, but it can kind of get confusing. So my best example is when I was a senior in college, we had to do a senior paper, and I decided I would do one on vitamin C. Ends up at that time, a guy named Linus Pauling, who had basically discovered covalent bonds, had decided to come out on it as a big proponent of vitamin C. And of course, people were like, he got Nobel Prize. So people were like, dude, this is a Nobel Prize winner in chemistry, but he's talking about vitamin C, must be right. What ends up that vitamin C is probably really good for you, but not maybe as good as Linus Pauling was talking about in those days. So like me talking about what we're talking about today, cosmology, it might be a little bit dicey, but we'll try to walk through things in a very logical way. So A little grace, please. Remember that I'm not that bright. So one thing you have to be remembering is that, they say about PhD, right? Piled higher and deeper. And what we always say is that, you learn more and more about less and less. Pretty soon you know everything about nothing, right? So that's where we're at. All right, we're going to ask a lot of questions in the beginning. We're not going to give any answers, all right? But I just want to kind of frame this whole conversation in the sense that we're talking about big things, big questions. What is the ultimate reality? What is the origin of the universe? That's one way that we will talk about, life and man. What if anything went wrong? Why are evil and suffering and death in the world? That's a big one. What if anything can be done about evil, suffering, and death? How should we live? What are the proper motives, standards for human conduct? What happens when we die? Where is, cosmic history heading? And how can we find trustworthy answers to the questions of life? Believe it or not, this list pretty much sums up all the important questions in life. It's 9 questions. For goodness sake, it's pretty crazy. You'd think there would be like 1,000, but there's not. There's actually, this one, even these ones here, I was thinking, well, we could probably condense some of those. All right, so now we're into really small text. Eric warned me that this was probably a bad slide. But anyway, so I'll just read it, which I hate. What does this list of questions mean to me and maybe to you? That if we take a step back, a spiritually equipped human being, I'm assuming that if you're in this room, you probably think that there's a spiritual component to who you are as a human. A spiritually equipped human being with intuition, reason, language, community and communication, conscience and hope, challenged by the questions of life. These are innate questions. These are questions that we literally were born with. Nobody came and asked us necessarily. We one day woke up and said, I wonder about this stuff. That we have curiosity about the answers, and that there's an existential urgency. We believe that these things are important to us. But we're ignorant of the answers. The answers are not from within. But to find them, we actually have to look without us. Now, this is obviously in direct conflict with some other world religions, but this is just my perspective. And that situated in an imaginable, messy religious and philosophical world, the questions are few and easy to understand. The possible answers are few and easy to understand. And the possible worldviews are very few and easy to understand. That's the good news. The bad news is there's a lot to think about, but the good news is that we can actually, if we want to, if you're interested, we can do that. And we're free to seek the truth or not. We can decide to live in the hole, or we can decide to look around and learn some stuff. All right, so there's actually only 3 real big worldviews. And remember, the questions are few and easy to understand. For example, what happens when we die? I'm sure you guys have all thought about that. Really, there's only 3 answers, and they're pretty simple. The lights go out, done, buried, dead, gone. That's the naturalist view. The soul reincarnates. So there is a soul. So the first one is no soul. Second one, there's a soul, but it goes off and then comes back. And that's a pantheist view. And then the soul goes to heaven or hell, and that's the theistic view. Really is kind of a short list. And you can literally go through the 9 and get down to this, and every single one you can get down to a relatively short list of answers. All right, a few more questions. Sorry, bear with me. What do we mean by the cosmos, our universe and reality as a whole? Did the cosmos have a true beginning? Did it have a beginning at all? If so, who or what caused it, and how did it come into being? When and how did the orderliness that we now observe in the physical universe arise? It's actually a big question, because the universe is super organized. It's crazy. For me, one of the reasons why I went into science is I look around and go like, this is amazing. Does the cosmos have a purpose and a goal? Now we're coming away from the science and maybe talking a little bit more philosophically, but can we know that with certainty the answers to these questions, and if so, how? So many questions in so little time. All right, so some fun. Let's focus on one question. What is the origin of the universe, life, and man? In the beginning, the universe was created. This made a lot of people very angry and has been widely regarded as a bad movie. All right, so obviously we probably don't think that. But so where should we start? Phew, finally, it took too long. A few more questions. Enough already. All right, so let's focus on one thing. What was the beginning of time? What happened before that? And how does God fit into the whole picture? All right, so like most things, in order to talk about stuff in a short period of time, we'll have to frame things in a certain way. So this was my idea, and so since I'm talking, I get to decide. So we'll need to make an assumption. So for the sake of our conversation, let's call the beginning of the universe, of our universe, the beginning of time. And believe it or not, there's a whole other conversation about time and what is time, now, and was time always, or did time literally begin? Is God out of time, which is what I think, and anyway, but that's a big deal, so we won't talk about that. But the reason why I'd like to do this is for two really good reasons. One, we can never really know what happened before that. I mean, we as people living right this second. And we barely know what happened after that. So literally before the creation of the universe, something did happen, something occurred. I mean, something was in existence. We think God was there, and but really after that, and certainly up until what we can look around and see, we barely know what happened. So we're going to have to limit our discussion to that kind of space. All right, so what are some of the options? So there's two big buckets, as you can, and hopefully, nobody out there is going like, oh my goodness, I never thought of that. You guys have been around for a little while, and some of you for super long. All right, ladies, sorry. I know you guys weren't there at the beginning, were you? No, okay. I was going to say, how cool would that be? You come up and, the oldest person on earth died last week, 115 years. So you guys could live for like a lot longer. All right, what are some of the options? So there's two big buckets, kind of according to Genesis, and these are the two big buckets, and then we're going to talk about some stuff that could be in between. So according to Genesis, and we'll go into Genesis a little bit because, this is church and we probably should read some scripture at some point. So the sun was created after the world, which is interesting, whereas in evolution, it was present before the world coalesces. The grassland, plants, trees were created before the sun, and then the other ones after the sun for life forms. And so you can get down, but when you get down to this part here, the age of the universe, less than 10,000 years. So this is really an extreme version of creation theory, where this is what's called a young Earth theory, super young, so 10,000 years, very young, versus about 14 billion years for the universe, for the Earth, about 4.5 billion years, and the age of the earliest life forms, about 3.5 billion years. And so where humans came from, which I think is important, from Adam, and then who God created, versus we evolved from nothing, and then into higher and higher order organisms. So why do people believe in evolution? Why do they believe in God? Why do they believe in evolution? But since we're talking about evolution, this is an important concept. People's belief system drives their worldview. In other words, you'd think that people would look at the data and go and come to a conclusion. And as good scientists, it's remarkable to me when this doesn't happen, when they come to a conclusion, and I go, what? Well, just look at the data. It doesn't support that. I mean, literally, this happens to me every day in my real job. And so I have to slap them around and poke their nose in it, and I go like, do you see it now? And they go like, oh yeah, I see. Okay, good. Of course, because I'm always right? But instead, what they'll do is they'll say, well, I have a worldview. I don't believe in God. And so, but there's this information. So how do I, cart before the horse kind of thing. So if you don't want to believe that there's a God, you build a worldview that doesn't require a God. Pretty obvious. And evolution is thought to eliminate the need for God in terms of our world. So if you're a Christian and believe in God, why might you believe in evolution? Because there's probably some people in this world, in this room, I'm sure, that have grown up believing in evolution. Well, number one, like I mentioned before, smart people develop the theory. I mean, super smart people. I mean, Darwin, he's actually a very smart man. It's what you were taught in school, probably taught by your parents. And you never knew there was another option. Okay? And remember, the people that have been promoting evolution have the no-God worldview in general. And there's a lot of Christians who are scientists, who are not Christian scientists, by the way. All right, so what does the Bible say? And in Genesis, we're going to kind of zip through this because this whole section in Genesis is pretty long. But this is This is really the biggest chunk in the Bible. And believe it or not, there's not a lot else. I'm not saying that there's nothing, because even Jesus actually talks about Noah. People are like, well, Noah never happened. Well, actually, Jesus in the New Testament refers to Noah. So Noah did happen. Now, whether or not you believe that, God was able to bring all the animals on the ark and how big the ark was and how they fed them all and all that, that's an interesting read in and of itself. So we're not going to talk about that. But for the most part, this is where almost all of creation theory comes from. And a couple things that are interesting, it's kind of highlighted some stuff. So in the beginning, God, so I think the verbiage in the text is interesting. In the beginning, God, okay, so God was in the beginning. He created the heavens and the earth. So that really is kind of interesting. And God said, let there be light, and there was light. But what's interesting is this is not the light of the sun. This is light, and people kind of are thinking, what does this refer to energy and, kind of a creative event that has to do with God putting energy into the universe. And then he said, let there be a vault between the waters, and separated the water from the water. Water from the water? What does that mean? So God made the vault and separated the water under the vault from the water above it. So clearly there was energy, and then there was water, and it was kind of this swirling thing. And God called the vault sky in the evening and the morning. And then let the water under the sky be gathered in one place, and let dry ground appear. Oh, so now we actually have ground. So before, remember, there was probably some sort of a core, and then the water coalesced. And he said that we call these seas. And then he creates, we count the days. So we got the first day, and then the second day. And then he creates seed-bearing plants and trees. That's the third day. And then the day and the lesser light given into the night, he made stars. That's the fourth day. Let the water teem with living creatures, and let the birds fly above. The fifth day. And then let the land produce living creatures according to their kinds, which is actually, according to their kinds, has become kind of an interesting vernacular in the creation verbiage when it comes to after their own kind. In other words, when talking about evolution, we're not talking about, and we'll get into that a little bit later, intermediate species. There's no mixture of kinds, so there's no half of dog and half of a cat, so that you have one kind. I know, kind of a weird visual, huh? And then let's make mankind in our image and our likeness, and so obviously the sixth day was a big day. And so just before we leave this, because that was the scripture piece, and we should talk about it just for a second. And then on the seventh day he rested, right, which is nice. I like that rest part. So were the 6 days 6 literal days? I think people talk about that a lot, and I don't know. I don't know the answer to the question. Could God had made all this in 6 days? Sure. Yeah, I mean, he's God, right? And so I think that's a possibility. Could it have been longer? Yeah, I think that's a possibility too. So before we leave this, I want just to kind of leave you with that thought that, and people get really crazy about the day, the duration of the day, and some people, like Pastor Eric was saying, are super hard-nosed, and they go like, yeah, it's a literal day. For me, personally, it's not a big deal. If you want to go to church on Saturday, that's cool. If you want to go to church on Sunday, that's okay. This falls into that bucket for me. But once again, that's just my opinion. All right, we're going to talk about, there's a large number of things, and depending on how much time we have, you guys are going to say like till 3, right? That's what, okay. But I picked out the top 5 things that are important, mathematical and scientific aspects. You say, well, you're a scientist, how are you talking about math? Okay, but it's important. And matter of fact, the first 2 things are going to be mathematical, I'm sorry. Okay, number 1, probability. The reason why I think this is super important is because it ends up that even in 14 billion years, what you see around you theoretically could not happen. Could not happen in terms of any evolutionary scenario. It just can't. It's not long enough. You say, oh, how long does it need to be? It needs to be trillions and trillions of years. So and of course the data, even for an evolutionist, doesn't support that. Even the oldest Earth theory, oldest universe theory, is on that order of magnitude, right? And so you kind of go, oh, so then why did they think that? Well, let's not talk about that. But let's talk about, we're going to start poking some holes in evolution now. All right. Dr. James Cobbage applied the laws of probability to the possibility of a single cell coming into existence by chance, and in the same way, a single protein molecule and even a single gene. Even having amino acids bind at a rate 1.5 trillion times faster than they do in nature. So he actually was even erring on the side of probability, maybe for some reason being different at some point in time. He found that to provide a single protein molecule by chance, and proteins, we consist primarily of proteins, by chance, combination would take 10 to the 2262nd power years. That is a big number. To get a single simple cell would be 10 to the 841st power years. That's a super long time. And this I think is an important, so I always think, okay, so that's a big number. What does it mean? According to Amroboro, a French scientist and expert in the area of probability, an event on the cosmic level with a probability less than 1 out of 10 to the 50th power will never happen. So literally, there's some things that, on a probability basis, and I'm not saying that they could never happen, but they can never happen, right? All right. And then this is just, it's just always fun to see what does that mean in terms of, kind of some fun facts. The chance of higher life forms having emerged this way through evolution is comparable with the chance that a tornado sweeping through a junkyard might assemble a Boeing 747 from the materials within. I mean, it's just, these things don't happen. I mean, I'm sure you guys have heard the analogy of you put 1,000 monkeys in a room typing away and how they come up with, it doesn't make sense. It's just, these things don't happen that way. Creative things require creative input. This is the reason why. The second law of thermodynamics. A system will always go from order to disorder. And they put a little parenthesis here, open or closed, because people for a long time said, well, that's only for a closed system like our universe. It ends up that that's not true. Even for an open system, which some people think our universe is open, this is still true. Things will always go from controlled, orderly, to chaos. And you can just look at my desk at work. It's, I clean it once in a while, and then it's going to be a disaster. I mean, just look at our own human bodies. We start as this, as my little niece, this beautiful little baby, and we end up, all nasty. I'm speaking for myself now. So the second law of thermodynamics states that although the total amount of an energy in the system remains constant, the amount of usable energy is constantly decreasing. Because what happens is as you use up energy, you create heat. And this law can be seen in most everything, where work is done, and work not necessarily being go to work, but work being from a physics perspective. Energy is expelled, and that energy can never be used again. As usable energy decreases, decay increases. All right? It's just a very, very simple thing. Herein lies the problem with evolution. Then if the natural trend is toward degeneration, then evolution is impossible, for it demands the betterment of organisms through mutation. And even the term mutation is interesting because it almost infers that things are getting worse. They're degrading. And evolution requires non-living matter from the very beginning to be turned into a living organism. The term is amogenesis. And this has never been observed. The closest thing of people of God, and believe me, people have tried really hard on this because, once again, their worldview is they want to believe that this could have happened all by itself. And so they've tried really hard to make simple amino acids, and they did. People, when they actually made some very, very, like glycine is the simplest amino acid, it's just a little guy, and they were like, oh good, so that's the only one they ever made. They didn't make, and we were making up 20, and there's some of them are nice, bigger deals, and that was it. And people have been trying super hard, so you kind of go, it's kind of interesting. All right, so when Eric and I were talking about doing this, it was kind of funny because I decided that, and I hadn't really done much thinking about evolution historically. I'd always had kind of a young Earth idea, and we'll get into the end why that's the case. But I heard this term macro versus microevolution because I always knew of evolution, and then I knew of natural selection. But it ends up that people use these terms, natural selection meaning microevolution and macroevolution being, for me, the big E evolution. So natural selection is basically the ability for organisms to adapt. And that's what Darwin demonstrated, that if you had selective pressure, if you had either environmental pressure, or you could literally demonstrate in a petri dish with bacteria becoming antibiotic resistant, that a number of bacteria would survive. And that's true, for larger organisms as well. But what ends up happening is you don't see new traits. What you see is traits that are selected for depending on the selective pressure. So if you had, in one of the examples that Darwin observed was, you had some birds that had longer beaks, and when the climate shifted and things got dry, the birds with the longer beaks survived because they were able to dig in and to get the food, and then the birds with the shorter beaks ended up dying off. What's funny is, and a lot of the stories that you hear in the books and whatnot, they don't tell everything, because of course they don't want to talk about the things that don't agree with their worldview. But it ends up that, of course, it rained again later in these islands, and then lo and behold, birds with short beaks came back, and it's just kind of funny. And this is another little interesting thing. People have been working on fruit flies for a long time. It ends up that they are a nice model system to observe and to do genetics on. And when I was an undergrad, we did some fruit fly stuff. Kind of a funny story. I was doing my experiments, and all my flies died. And so I was going to get an F, so I withdrew from the course, and because you had to finish. I withdrew from the course and spent. And then they let me start over. They said, "Well, here's some more flies." Because what you had to do, you had to figure out the genotype from the phenotype. The phenotype is what you see, and the genotype is the DNA piece. And so they let me finish. I spent all Christmas, Laura remembers, all Christmas working in the lab trying to finish. And I did it, so thank goodness. But anyway, so people have been working on fruit flies. We've been working on a lot of small organisms, worms and stuff like that, just for years. E. coli, these small bacteria that we work on at work. People have literally mutated the heck out of these UV light, chemicals. And what you can do is you can make weird stuff happen, but you don't make worms out of flies. You don't see new things. And people, so this is equal to 37,500 years, which you kind of say, well, it's kind of short, but really in the time that we think human beings have been around, but well, it depends on what you think we call a human being, but even the evolutionists think that literally human beings have been around for a relatively short period of time, that we would have seen something. We would have seen something new, but we haven't. When I made a little joke about the donkey. The other thing that ends up happening is a lot of cross-species propagation actually results in a sterile organism. All right, the fossil record. This is probably the most interesting one. Even Darwin admitted that because he had been looking at the fossil record for a while and saw that there were some gaps, but figured, well, we just haven't seen enough yet, so the gaps will be filled in over time. Ends up now 130 years after Darwin, literally billions of fossils have been looked at, and there's some problems. There's some problems with the fossil record, and that is there's not one transitional form that's ever been found. What's the transitional form? Well, that's the dog-cat. That's the one that, and it's not just the dog-cat. I mean, using that example because these are animals that, and I'm not even sure that, people think that those are connected, but, and it's not just that you'd have something that's half dog and half cat. You'd have something that's, let's say it was from cat to dog. You'd have something that's 1% dog, and then 5%, and then 10%. So you'd have this whole series of transitional forms that you could see. You could see examples of them in the fossil record. But you don't. You see dogs and you see cats. You don't see anything in between. And that's a real problem. All right, but some more on the geological column. So you've been to Grand Canyon, you see, or just driving along the road, you see this strata, that gets exposed. That's the column, and the idea is that over the course of the history of the Earth, those layers were laid down, right? And so, and early on, when people were first starting to look at this stuff, they said, well, what you have is at the lowest level, you have the simple organisms, and then you see fossils there, and then you get to higher and higher, and then you get to man at the top. What's the problems with that? The strata appears to be laid down suddenly and catastrophically. There's mass animal graves, so it appears as though that in certain periods there was a catastrophic thing when there's like all these animals died and boom. There's live action fossils, so there's like a deer golfing, just kidding. But the deer will be eating or jumping, and then all of a sudden, boom. And there's polystrate fossils, meaning there'll be a tree going through several layers. And there's a lack of erosion, so that means that even if you look at a given layer, which, if it existed for a long period of time, that it would have been there, and then part of it eroded, and then something else on top. You don't see that. You see these layers being laid down relatively rapidly. Out-of-place fossils repeatedly contradict the standard evolutionary scenario. You see land animals, fish, and birds side by side. Horse prints next to dinosaurs. And by the way, I don't have any problem with dinosaurs. Dinosaurs fit in fine. There's once again, there's the data. The data is there's dinosaur fossils. So yeah, do I believe there's dinosaurs? Yeah, of course. Human footprints found in strata, quote, millions of years old. And people talk about the evolutionary tree. If you've seen this, and a lot of this, if you went to school, then you've seen all these things. You've seen, I think the most famous ones are, you see the monkey, the little chimp, and then the ape, and the monkey, and the human, right? The little silhouettes. You see this one here, the evolutionary tree has no trunk. It's a joke. There's no evidence that multitudes of life forms evolved from a few simple ones. Instead, fossilized life appears suddenly complex, diversified, and worldwide. The lowest layers, like the Cambrian layer, and they're Precambrian, whatever, but even then they include fish, worms, plants, and vertebrates. Well, that sounds a lot like the Genesis story. Oh, that's funny. In fact, what's funny is that these three layers reveal even more life forms than exist today. Well, why is that? Because some of them are extinct. Yeah, of course. That makes sense.